Last time we were talking about the use of formal charges to help us pick the Lewis dot structures that are most important for a particular compound. And what we said was sometimes there's only one Lewis dot structure that gives you an octet for everything, and all the rest of them have some deficiency. But sometimes that isn't true. Sometimes you can write perfectly good Lewis dot structures that have octets for everything, and yet they are not equally important. And the formal charges are the things that we use to find out. So this takes us back to exercise or example with our phosgene, COCl2. And it says the result that we got back from 9.7 is Lewis dot structure A here. But Lewis dot structure B and C both have OK octets. So it wants us to use something, which will be formal charges, to allow us to pick the right ones here. So what I'm going to do is just calculate the formal charges for everything. Now I already know a few things. Double bonded oxygen has a formal charge of 0. And you can figure that out. It would be 6 minus 4 minus 1/2 of 4. So that would be 6 minus 4 minus 2, that's 0. So this is 0. A 4-bonded carbon also has a formal charge of 0. A 1-bonded chlorine, let's look at that one. That would be 7 minus 6 minus 1/2 of 2. So that's 7 minus 7 is 0. So this is 0. And this is a single bonded chlorine down here, so this will be 0 as well. So we look at this, these are all zeros. That's as good as it gets. As far as formal charge goes, that's perfection. So let's look at some of these others. A single bonded oxygen, let's see what its formal charge would be. Formal charge of a single bonded oxygen would be 6 minus 2, 4, 6 minus 1/2 of 2. So that will be -1. So already this doesn't look as good. A non-zero formal charge is an element of less stability or less importance, if you will. This is a 4-bonded carbon here, so that's 0. This is a 1-bonded chlorine here. We saw that's 0. What about a 2-bonded chlorine? Formal charge of a 2-bonded chlorine. So that's going to be 7 minus 4, 2, 4, minus 1/2 of 4. So that's 7 minus 6. That will be plus 1. Okay. So we have a -1 and a +1. Once we had the -1 and the 2 zeros, you could figure algebraically this had to be a +1 because the sum of the formal charges for a molecule always adds up to 0. They're going to be 0. So you don't have to calculate all of them. If it's an ion, the sum of the formal charges is going to add up to the charge on the ion. Okay, so this one is not as good as that one. Clearly B is less important than A. What about C over here? What about the formal charge of a 2-bonded carbon? So that's going to be equal to 4 minus 1/2 of 4. So that's -2. That's not good. The 4-bonded oxygen here turns out to be positive 2, not positive 4. Positive 2. This is 0, and this is 0. So of these, A is more important than B, and B is much more important than C because we're getting 2 big formal charges here.